Hi everyone, and welcome to class number 4 of flm204 here at FX PhD. And today we're going to dive into some expressions based upon a little bit of the discussions that we had in the forums. But before I do that, I just want to take one more thing, beating the batch effects horse one more time. Let's go ahead and go into batch really quickly with Angie here. And I'll just grab these three clips to demonstrate this. One thing I just want to talk about is the saving of batch effects setup. So right here we have a post batch effects here, and if I double click on it, we come down here in this layer and you can see I've got the color correct and the spark node. What we want to do is go ahead and let's say you want to save the batch effects. So you go ahead and you're here on this level and you're going to save, and we'll go ahead and save flm204 test1 all. Okay. And then I'm just going to go ahead now and I'm going to go ahead and save selected, which means you want to save the selected items in this. So if I'm going to go ahead and hit all just to make sure I have everything selected, I'll go ahead and save this and do selected. And it warns me. Okay, so let's exit out of this BFX here. And then one thing before we set this off again is I want to go ahead and I've got this shot here with the batch effects. And what I want to do is actually, I can take this clip by doing Alt-Shift and dragging it out here to the batch schematic, and you can see that this has a batch effects on it. If you just look at the timeline, you can see you've got it here. But one of the cool things about this, and this is really useful, is you can go ahead and select this. And if you go to Basic, you see you have Expand One or Expand All. That's basically expand one layer of batch effects or expand all. And in this case, I only have one layer. But if I hit this, it actually brings out the original source clip here to my desktop along with the color correct and spark node. It's a really great way of getting access to certain clips and setups and so forth. Okay, so that's just one thing that I didn't mention in some of our previous classes. Now I'm going to go ahead, I'm going to delete this, and let's actually just go ahead, exit out of batch and hit Alt. We've got a brand new setup. I'll go ahead and bring this in, and let's just go ahead and just for sake, let's go ahead and take this in. And so we've got this. And if we go in here and we take a look here, so let's just go ahead and let's say you want to load that batch setup. I'm going to first go ahead and save the selected one. If we load that in, you can see what actually happens. We actually load those selected nodes. They're output to this output node, and we've got the original clip here of Angie, but we can just get rid of that in the output node. And then you could, if you wanted to, you can just use these setups as they are by, doing that. Okay, so basically that's the way if you want to load up an individual layer of a batch setup, that's what you'd get. But let me go ahead now, and if we exit the batch effects, this is what we still have here on our schematic. But let's go ahead and go back here. And if I go ahead and do load batch and load batch all, this is actually what you get. So what's the deal here? Well, the reason I loaded these Houdini clips in is it makes it kind of easy to see what's going on. Basically what's happening is we're loading the entire batch setup that we had last time. In other words, when we hit save all, the save included that upper layer batch that was there. So it includes all levels of batch, okay? So then if you go in here, you can actually see that's back to where we were. Exit out one layer. You can see this is our original batch effects here with that entire batch setup, and then exit out to our normal batch level. Okay, so that's the difference between all and selected. All is great because you can just save everything in your batch setup. You know it's all going to come back. If you're going to load an all, you'd go ahead and generally load it from this layer. If you want to save a specific batch level, you would do it as selected, and I usually select all if you're going to do that. Okay, but you can, of course, limit it to a tree, a branch, or selected as well. All right, so that's just a quick look at the, a little bit more about the timelines than what we had in the previous two classes. Okay, so let's go ahead and put the timeline to rest and have some fun with expressions. And what I want to talk about is using expressions to deal with blur and positional blurs based upon the layers. And this is some stuff that actually came up in the forums. And if you guys didn't see that, I wanted to get everyone up to speed, so I apologize for that. And this is kind of some advanced stuff. This is stuff that I ended up doing in the previous expressions course in the last class. What I'm going to do is kind of break it down and really cover it a bit more hardcore and in detail than I did before. So let's go ahead and go into action. and take a look at this setup. And this is just effectively what the setup is. I'll go ahead and zoom out like that so we can see the whole thing. But I've got a blur amount axis here. And basically by moving the axis, what's happening is certain layers go in and then out of focus as they go back based upon the layers, okay? These aren't positioned in 3D space. I'm just dealing with image 1, 2, and 3. And actually you can see that here. If I go ahead, you can actually see the layers. So you can see image 1 now getting blur sharp and then blurry, and you can see them kind of transfer all the way down. Okay? So that's actually what's happening. I'm actually using this blur amount to control that. So let me go ahead and just show you the expression that I'm using to do this. We'll go ahead and I'm just going to go into media and I'm going to reset the channels here. And let's take a look at this. It's a simple layer blur. All right. So what I'm doing is I'm starting out with layer 1, 2, 3, and 4. I'm just setting blur X and blur Y to be either 10 minus the blur amount dot position dot X, 20 minus the amount, 30, 40, and so on. And then as I move the X and subtract the X, these values will change. Okay, so they're kind of offset. Each blur of the layer is offset by 10. So when I move X, the blur changes. Say we have an example value of 10 in the blur amount position dot X. You can see here that I get these various blur levels. You know, layer 1 would have 0 blur, and then so on and so forth down the line. So let's go ahead and enter that in a couple layers in action. And what I like doing when I'm doing this, notice how every layer is the correct number and the axis 4 relates to layer 4. It's just a really good way of starting, and you'll see why in a second because we'll actually be using the axis information. But when you're doing expressions and so forth, it's really good to try and make things as clear as possible from the start. So think about that before you set things up. Let me go ahead here in layer 1, and I'm just going to enter a value here in blur X, and we'll go ahead and do that, and we'll just say for this layer we'll do 10 minus blur amount dot position dot X and enter. And then what I like doing is doing a copy and link to Y. Why do I like doing that? Well, that's because this Y will just refer to whatever I have entered in X. So if I change X, let's just say we change this to 100, Y will automatically follow along without that. Okay, so we'll go ahead and undo that. So that's why I like doing that. So let's go into media layer 2 and blur. And I'll just do a couple of these to begin with. If you do up, you'll get the last thing you entered. So there's 20, and we'll do copy and link. Leading media layer 3, a right bracket, do 30. Copy and link. And then media 4, let's go ahead and enter that expression and do 40. And copy and link that. Copy and link. And let's go ahead and reset our blur amount to 0 here. Okay, so we basically got 4 of our layers here set up. Let me go ahead and I'm just going to hide these other ones down here. It's like doing that as a quick way of hiding things. So now if I change blur amount, you can see that I'm now going from these really out of focus in negative values. And then as I get down here, they come in focus and come in focus and come in focus. But what's happening now, and this is one of the problems Craig ran into when he was asking about this expression in the forums. What's happening is if we take a look at the media layers, we're actually ending up getting zeros here in the blur channels. And why is that? Well, let's take a look what I've got set up here. If I put a value of minus 30 in as the blur amount, you end up getting a value of minus 20. But the thing is, the X and Y blur values within the layers, actually anything negative will actually default to 20. And so we end up getting for these 0, 0. So these will actually, if you get far enough away, they'll actually always remain crystal clear and not blurred a bit. So what do we need to do? We need to find a mathematical function to help us with that. And of course there is one, and it's called the absolute value function. Basically you feed it a number and it returns the absolute value of the number, which is a positive result. All right. So let's go ahead and take a look at this. What we end up getting, if we have blur X, blur Y, and we say absolute value of our blur amount dot position dot X. So we get absolute value of 10 minus 30. So that's equal to an absolute value of negative 20, and that returns 20. All right. And that returns 10, so on and so forth. So let's go ahead and do that. Let's go ahead and go into action and enter that. Just really quickly on a couple of these. If we enter this, basically we'll go ahead and do absolute value there. And again, the nice thing is there, it changes them both, and you can see why you want to do that now, I hope. Go ahead and enter this. It's a little easier to do the back arrow than editing. I really wish they had a bigger box to edit these expressions with. You'll especially see that later when we start getting a bit more complex. And then let's go ahead and do that. And so now I'll set this to 0. And we'll do that minus. Okay, so they're all really blurry. And as I bring this blur amount down, let me go ahead and switch to 2-up view. Control home here. Let's go ahead and zoom out there like that. And then over here, let's go ahead and check out our values so you can see them here. You can see the value change as I change the position. You can see what's happening. Okay, and now you can see if we hit that 10 where we get 0 and we start getting higher, the absolute value function kicks in up here, and these cycle back up to positive values, and so our blur works for us correctly. All right, so that works really well for us. But what happens if you want to reposition layers and you want to change things? You want a blur to happen differently. Well, you're kind of stuck to what you've entered in each of these expressions. And I would suggest that potentially a really good way of doing this is to go ahead and use the Z position of your image layers and then have an axis that controls where things are in 3D space and are in focus. So let's go ahead and take a look at that. The basic math that I'm going to use is actually a positional layer blur. What I'm going to have is I'm going to have an axis called focus, and I'm going to use that position to say this is where the layer is in focus. So I'm going to have a function that's going to use the absolute value function. I'm going to say absolute value of focus.position.z minus axis1.position.z. Okay, so let's go ahead and see how that works. I'll go ahead and go back into action. And I'll switch up to 1-alt view, and let's go ahead and reset our media layers again. And actually, if you take a look at this, I've already got it set up in Z space for us already. So let's go ahead and instead of blur amount, let's just make this easy. I'm going to call this focus. Okay, so we've got this focus position here. What I'm going to do is let's enter that function in here on blur X. That's going to be, what do we say? Absolute value of focus.position.z minus axis1.position.z. And again, this is one of those things where I'm going to go ahead and set this back to 0. Actually, let's see where this is. This is at 586. I'm going to set this at 586. Okay, so now right now the focus is operating the same Z space as this, so it's not in focus. Or so it's actually not out of focus, I should say. But I was saying, just notice again how I'm using those axis values on media layer 1 and 2. So let's go ahead and copy and link. So we get proportional blur. Go down to media layer 2. And let's go ahead and enter an expression. And again, I'm on media layer 2. I'm using axis 2. Copy. Link. Go ahead and enter this in. I got to say, I really, generally don't name all my stuff very clearly. But when doing expressions, I know that just right from the start, it's going to be a mind, I'm not going to say that, but it can be mind meld or whatever if it's not logical. And then I'll go ahead and say copy and link. Okay, so now you can see, let's go ahead and take this here. Go ahead and let's zoom this back a little bit. Let's take my orbit and just so we can see it a little bit more. And now, as I move my axis back in Z, you can see that I start to bring these various items in focus. Okay, and it's all dependent upon where the position is in Z. Again, notice I'm just dragging on the Z axis, so I know I'm only moving that in Z. Okay, but what's happening here? What's happening is my blur values are really getting high really quickly. And what I need to do is add a multiplier in this case, because it's a fairly simple setup. So I'm just going to figure out a way to add a multiplier. And what do I mean by a multiplier? Basically, it's this. I'm going to take it and take our absolute value result that we had here before and multiply it by this multiplier. And so you say you have a Z position of 500, and we end up being at 500. I take a multiplier times 0.05. The blur amount ends up being 25. Okay, so say I have 500 here times 0.05. I end up with a value of 25. So it's a really simple way. Now, how should I enter that multiplier? Well, what I'm going to do is I'm actually going to use an axis. And I'm going to call it blur multiply, blur mult. Why do I want to do that? Well, that's because instead of hard coding a value in as we did before, remember we had 10, 20, 30, so on with a blur mult, I can actually use this axis to control it and interactively decide how much blur or how little blur I want. So let's go ahead here. I'll go ahead and enter in that expression. Actually, I need to do it down here. Enter in the expression, and I'll take it now times blur mult dot position, and I'm going to use X for this. And then here, let's go ahead and do the same thing for axis 2. Same thing for axis 3. And the same thing for axis 4. Or layer 4, excuse me. Now, these are all 0. Why are they all 0? Well, that's because blur mult is actually 0. So I'm getting a multiplication factor based upon it being 0, which will always return a blur of 0. So let's go ahead and take a look at our result here. And now, if I take this blur amount and crank it up, you can see what's happening. Now, notice 1 is going to guess really high really quick. So what you need is more value of like 0.05. Okay, and you can see how that's starting to work, or 0.03. So now, when I move the focus forward and backward in 3D space, the blur values are actually much more reasonable. And why do I like that? Well, that's because the reason I really like this is if I take this axis and I position it back in 3D space, it's actually going to follow along correctly with what I have. So I can reposition these items all that I want, and I don't have to update. Oh, that's not the right one. Let's take nuke. Let's undo that because that's my blur multiplier. Let's take nuke 203, move it here, and move this back. Now, of course, what we need to do is go into our media layer and do a Z sort to get those right. But notice now, if I just move the position, all the layers follow correctly because it's actually theoretically, correctly following their position in 3D space. All right. So I think that's actually really an interesting way of tackling this problem versus just hard coding a value into the, into the layer blurs and doing things only as a layer and not really worrying about 3D space. And why do I worry about 3D space? Well, because doing this in 3D space can actually, and I'll show you in the end, can actually do some interesting things about flying your camera through. And also in a way, it kind of makes a little bit more sense if you're just thinking about cameras and so forth and depth of field and aperture and so forth. All right, but that's really a simple example of such things. What we're going to have to do is we're going to have to take a look at a couple other things. And I'm going to go ahead and show you kind of what we're aiming, what our end result is here for the rest of the class. Let's go ahead and load up this final. So if we take a look at this, I've got a couple different things going on here. I'll go ahead and orbit around the camera a bit. And let's go ahead and zoom out. I've got my focus point here. Okay, but my focus point actually controls things based upon X and Y and Z. So it's basically taking a look at where this axis is in relationship to all these other items within my scene. And let me see if I got Gaussian. No, I don't have Gaussian blur on. It just seemed a little slow. So blur amount, I'm going to go ahead and set this up to say 80. So you got things that are really quite blurry. What's interesting about this is that I have a couple values. I have this value called clear distance. So anything that's within 500 units of my focus will be clear. And then blur distance, anything that's 3,000 units away from my focus will have the blur amount of 80. And then anything between 500 and 3,000 will transition from being sharp to being completely out of focus. So let me go ahead and I'm going to go ahead and reset my axis there. Okay, so you can see here this is Houdini 101, which is located right near the 0 point, and it's within and close to this axis is sharp, whereas the flame, which is really here close to the camera, if we take a look at it in the top here, so there's Houdini, and here's flame, is actually out of focus. All right. So how did I do that? Basically, we need to take a look at a couple different functions and a couple different things so you guys can understand what's going on. Let's go ahead and go back to the slides. The first thing is an if statement. All right. It's basically saying if a condition, if something, if the condition is true, then do this thing, and if it's false, do this thing. So let's go ahead and bung up something just really quickly for this. Let me go back into action, and I'm just going to go ahead and let's say, let me just go ahead and reset all, and I'm going to go ahead and hide all, and then let's unhide this. All right, so I've got edit 201. What I'm going to say is this. Let's just go ahead and use the blur because we're working on blurs. I'm going to say if axis 1 dot position dot x is greater than 0, then let's set our blur value to be 20, comma, or 0. Okay, so anytime my x value, anytime I move the position in x, it's going to set the blur value to 20. If the value is negative or less than 0, or 0 or less than 0, it's going to set to 0. So right now, my axis here is set to 0. If I take it and crank it up to, say, 10, I've got a blur. All right? And the minute it crosses back over to 0, it's going to use that second part of the if statement and say, okay, I'm going to set the blur to be 0. Okay, so positive greater than 0, it's going to set my blur to be 20. 0 or less than 0, it's going to set my blur to be 0. Okay, so axis1.position.x greater than 0, comma, 20, comma, 0. So that's just a really simple example of using an if and then statement. Now the next thing that we have is we're going to have something called the length function. All right, and what the length function generally does is it returns the length of a vector, and a vector is something that's defined in x, y, and z. So it's got 3 units to it, x, y, and z. This function will also return the distance between 2 objects within action. So it returns the distance between, say, axis 1 and axis 2 is what this function will do. Let's go ahead and take a look in action here. And let me load up just this really simple thing here. Basically, this is just describing for you or showing you what the length is. So this is, say, this is axis 1, this is axis 2, and this gray bar is giving us the distance between them. Now, the great thing about this is this could look like, x and y, but it's true 3D. So depending upon where your object is in 3D space, you're going to get a correct distance. So that's really cool for us because what we want to say is, let's say our focus point is here and our object is here. We can use the length function to determine whether or not that should be blurred. Because, let's say we set the blur, distance to be 500. If this is 500, then we know to blur the layer that's associated with this axis. All right, so that's kind of where we're going with this. So again, that's basically kind of a crude showing of what the length vector is. So what I'm going to need to add a couple more things to our action setup to help us control this. So we've got the focus position, we've got the blur amount. But what I'm going to do is also set a blur none distance. And in other words, that's a distance from the focus position where there is no blur, kind of like a sphere of influence. of where there's no blur. And then blur full distance, there's a distance at which you have that full blur value that you'd expect. Okay, it's because it's far enough away from the point. So if you take a look at this diagram here, this is effectively what we have. I have the focus point here. We have a clear distance here set to 1,000, a blur distance set to 2,000. So whenever an object is outside of that distance, like you see here, it's going to be blurry. Anytime it's inside here, it's going to be clear. Okay? So what we're going to want to do is actually use that length vector to make a determination of whether the distance from this focus to this object here, this axis, is greater than 2,000. If it's greater than 2,000, we're going to say, heck yeah, blur it. If it's less than 1,000, we're going to say, okay, make it not blur. Make it not blurry at all. The kind of tricky part is here, in between this blur distance and the clear distance, actually transitioning from a whole lot of blur to no blur. Let's go ahead and go back into action. I'll just demonstrate this really quickly. Right now we have this edit 201 set up, and right now it's resting where the focus is, right there as well. I've got a whole bunch of axes here, so I'm going to go ahead and hide this axis just so you can make it really clear. So there's our focus axis is right there, and then there's the edit 201 axis, which is within the sphere of influence. Now as I move this axis, it's looking fine, it's reacting fine, and then when I hit this, you can see it actually slow down. It starts to blur more, and at this point it reaches its maximum blur. Okay, transition in shape. Now it's also important to remember these are circles here, but these are actually spheres, okay, because we looked at that length vector. It's measuring 3D space. It's just easier to look at it this way. So let me go ahead and let's use that if-then statement, and let's go ahead and just go ahead and start out with something really easy. So I'll go ahead and reset this channel here. And what we'll do is I'm going to use that if-then statement. So I'm going to say if. We're going to say is if the length, L-E-N-G-T-H, of focus dot position minus axis 1 dot position is less than blur distance dot x. In other words, that value would be this outer circle here. And I think I've got too many. No, that's right. I think I've got too many parentheses there. If it's less than that, then it's inside the circle. It's inside the circle here, and we're going to say no blur. So 0. But if it's greater than that, in other words, outside the circle, what we're going to do is we're going to say it's going to be blur amount dot position dot x. In other words, pull our value from that axis. And I did do this wrong. I really hate how oh, you know what? I left off position dot x here. So blur distance dot position dot x. There we go. So now if I move this here, it should remain clear. And since we're not transitioning, once it gets outside of here, it should pop. Okay, so that works. It's less than that, so it's going to be clear. And then the same thing, if we go ahead and take this down to y, or actually you can go this other way, it's anywhere outside here. So what we need to do is find out how to transition from this, where it's clear, to this, where it's blurry. And how do we do that? Let's go ahead and go out and play with some math. So I'm going to try and not lose everyone here. So basically we've got this length here. That length is the focus dot position minus axis 1 dot position. We just saw that. You can also see our various blur distances here. Now when we're here in the middle, this is where our transition problem becomes. And what I did is I figured out this using just relatively simple maths. Basically, we'll take the length, the focus position, and subtract the clear distance dot position. Okay? What does that do? That's basically taking the entire length of this yellow line and subtracting the clear distance dot position, which is the distance from the focus to here. So that basically leaves us with this little remainder here. So let's just say this is 1500. Remember, this is 2000, this is 1000, so right in the middle, 1500. So we have 1500 minus 1000, which ends up being 500. Then if we take and just do a really quick thing that we did before, that blur distance dot position dot x minus clear distance dot position dot x is 1000. Basically what I'm finding is I'm finding the distance between this point and this point. So actually blur distance here minus the clear distance, and that gives us the length of this, which is 1000. Now this is where it starts to look a little scary, I admit. Basically we've got, let's go back, it looks even scarier doing that. All I've done is taken this and divided it by this. But what I needed to do was actually enclose these in parentheses so we get that stuff to happen first. We get the order of operations correct the way we need it. So I added parentheses here and added parentheses here outside this whole thing. So it starts to look a little more complicated. So what we end up with is 500. This is 500 divided by 1000, which is 0.5. And then we just take that 0.5 and multiply it by the blur amount dot position, which is our maximum blur value. So if we had a blur value of 100, it'd be 50 here. So 100 here and 50 here. So our calculations are actually working pretty well for us at this point. This is just taking a look at the entire thing as we would enter it in. Once again, I started with this as our base, and since I want to get the order of operations right, I enclosed this entire things in parentheses, and then took blur amount dot position dot x and multiplied it by that. All right. So I'm just trying to show you how you need to add these parentheses for clarity and so forth. It really helps to kind of work on these on the side, maybe use a text processor just to make sure you got everything right, because debugging expressions is kind of non-existent actually. Okay, so let's take a look at it when it's right here. When our edit 201 axis position is at 1000. So we've got the length here of 1000, the length between the axis focus position and edit 1, or edit 201, axis 1 position is 1000. Clear distance, that stays the same minus 1000, so we get 0. This part stays the same, it's 1000. And so if we take the same function, we get 0 divided by 1000, which is 0. And that works. We get 0 times blur amount dot position dot x. We end up with 0. Cool. Now this is where it gets a little bit interesting when it's right at 0. Now this is where it really gets interesting, where it's right at 0. Our math gets a little nutty at this point. Basically, our length ends up being 0, but our clear distance remains this, so we get 0 minus 1000, we get minus 1000. This, of course, stays the same. So you get minus 1000 divided by 1000, which is minus 1. So you get minus 1 times blur amount dot position dot x. What happens is it goes from 0 to minus 1 here during this range. Well, as we discovered earlier, we had to work around the problem where if you had a negative blur value, it stays clear, no blur. In this case, now we don't care. We don't want it to have any blur at this point. So if our blur amount is, say 50, we get a value of minus 50, but in the layer menu, it doesn't matter. It's just going to be 0. So that actually works to our benefit very well. And then here at the end, you end up getting this setup as well. You get the length here to be 1500, and we're just back to where we were at the blur amount. It cycles back around. So that works out really, really well for us in setting things up here. So let's go ahead and go back into Action. And let's go ahead and load in this very simple setup where we have everything set up with the same Z. Notice again, I've got all these in the same Z value there. Let's go ahead and reset the camera back to normal, and actually we want to zoom out so we can see everything. So I've got the focus here. I'm actually going to hide these. I've got a clear distance here set to 300 and a blur distance set to 1000, and the blur amount is set to 40. So now if I move the focus around here, go ahead and drag this around. It's a little sluggish because we're doing some processing. You can see as I bring the axis closer to these objects, pretty cool, huh? You're actually getting something that blurs based upon the position of this object, of this axis. And then if we take it to another level, I'll just go ahead and, again, I've entered all these expressions in. Let's just go ahead and take a quick look at this. Let's go ahead and if we take a look at this expression, you can see that the expression now for media layer 1, it uses that same root expression, but it says axis 1. If we take a look here at our blur here, you can see it uses axis 2. So all we're changing is the number of the axis, and again, axis 2 is tied to media 2. Let's go ahead and load in the vector final that we have, which is pretty cool. And if we take a look at this, let's go ahead and do this and zoom out. You can see that as I move my focus point, we end up just interactively being able to blur and not blur the objects. Reset the camera. Again, very, very, very effective and very, very useful using stuff in 3D space. And by using, by using the values here of the transition, you know, we've kept it as flexible as we can. You know, I've got the blur amount. If I want to change the blur, it's not hardwired into our expression. I change the blur to 80, and everything just blurs a lot more than it did before. If I want a clear distance to be bigger, as long as I keep it below here, I can just say, okay, let's set this up to 1500, and more stuff remains in focus around this focus point. So again, really, really flexible. You know, you can even have it just almost transition to be no blur if you wanted. So we could just take this down to 20, or you know, nothing clear. So that works as well. So it really gives us a lot of flexibility in adjusting this parameter. Now what this really makes this cool is to actually allow us to have a camera fly through. So I can actually take the camera and fly through this. Now right now that won't happen because if I take my camera, go ahead and move the camera, you can see that the blur's not changing. That's because we're just traveling through a static scene. What I actually need to do here is I actually need to take my axes and have it take the camera information into account as well. So what I'm going to do is actually add another axis. This is going to be kind of our new focus point. So I'm going to call it focus new. And I'm going to parent it underneath the camera, just like a point of interest. Now a camera, what I want to have set up, I want to have it set to free mode in our case here in working with it. It's just going to work out better with this calculation. This is just going to be kind of a cheat for a single straight camera move in past these objects. I'll show you where it falls apart here in a second. But anyway, so what we've got, let's go ahead and switch here to the top. I'm going to take this focus new and I'm going to position it back in space. So let's say minus 2000. So I've got this here at minus 2000. When I move my camera, however, the camera moves with, the axis moves with the camera, but this value doesn't change. So what we need to do is calculate the value of actually where this is in 3D space. And that's really just simple enough to take and let's go ahead and let's just put this back to say 2000. Just simple enough to say take the camera position and add this position. So what we'll do is I'll take this focus. I'm actually going to rename this as focus calc just to kind of let us know what's going on. I like doing this. No, there's a calculation there. It's going to modify these expressions. I don't need to re-enter everything. And for the position, I'm going to enter the expression that's focus underscore new dot position plus focus calc dot position. Not focus calc, sorry. Plus camera dot position. If you take a look, that focus calc is minus 100 because we got a camera position of minus 2000, an axis position of, say, minus 2000. But as I move the eye, the camera eye here, you can actually see that the focus calc here is actually changing position. I'm going to go ahead and hide this. Let's see if I can leave that like that. You can see that the calculated axis is moving with us. And as it moves, you can see that our blur is changing based upon where our camera is as we fly through these objects. Okay, so you can do things, you can do things like, we can do, in this case, a Z rotation is okay to do. And if we move here in the eye, it's going to be okay, animation-wise. We're still going to be able to maintain our blur and so forth. But the problem becomes, I'll go ahead and take this off, the problem becomes when I start going ahead and doing, say, a Y rotation. If I do a Y rotation, our calculation comes off. So you notice how that's not working with us and it's not following along. Technically this should be following along with that. Now, bonus points, like I say, for someone who can figure out how that works. It actually can be done, and if you're interested, maybe I'll show the trick in a future class. Just let us know in the forums, or let me know in the forums. But again, that's just now using simple calculation to determine where this new focus point is. And again, just like before, you can go ahead and we can change our values. We can change the blur amount. We can change the clear distance. Blur distance here is, let's say, 2000. And we can make our clear distance here to be quite a bit bigger, so we have more objects in blur and so forth. So again, it really is quite flexible when you're working with expressions this way. That'll wrap it up for this week. I'll go ahead and send out this setup file, and it won't have all these images. I guess I'll go ahead and send out these images with it, and you can play around this and take a look at it for yourself and see how things are done. If you have any questions, drop by the forums, and I hope you've enjoyed this look at blur and position. We'll see you next week. Thanks.